Hello everyone, welcome to Sangam tutorials, SP Gubbi online classes for NCERT and 10th standard and Cbse 10th standard classes for mathematics and science. So in previous session of mathematics we had discussed regarding the riders on AA similarity criterion. So if two triangles are equiangular, then they are similar, or if two triangles are equiangular, then their corresponding sides are proportional. So this is the AA similarity criterion. So we had proved this criterion in the previous sessions also. So and in the last 2 to 3 sessions we have proved many riders on it, and in today's session we will be going with a very important rider, 2 riders and 2 numericals. So after this, in tomorrow's session we will be going with a new criteria for similarity of triangle, that is SAS similarity criterion. We will solve problems in tomorrow's session, right? So in today's session, this particular problem which is on the board will be asked in your examination for compulsory 4 marks. It's very important, and parallel to that it's very easy. It's very easy. So at the end of this session you will be a master in all the 4 problems what I am going to present tomorrow, that is in today's class. I hope you will listen very carefully with keen observation. If you want a repetition, please go back in the video, watch it once again, write down the notes, practice problems, and get ready for the test on similar triangles on the coming Sunday. So get ready for that. Right, wish all the best. In trapezium ABCD, it's a very simple problem. It's very simple. Concept is very simple. We have to apply all the previous knowledge what we have learned. So among them, one is the converse of BPT. I hope you remember. So when a line divides any 2 sides of a triangle proportionately, then it is parallel to the third side, that is the converse of BPT. And BPT, if a line is drawn parallel to a side of a triangle, then it divides the other 2 sides proportionately, that is the Thales theorem. So using this concept, and we are going to prove this particular rider. It's a very famous rider, very classical problem, right? So in trapezium ABCD, so this is trapezium ABCD. So where, according to the properties of trapezium, one pair of sides will be exactly parallel to each other, and those sides which are parallel to each other are not equal, and those sides which are equal, they are not parallel, because when extended on both sides, they are going to meet at a point somewhere above the trapezium, right? So here in trapezium ABCD, AB is parallel to CD. It is given, very important result. EF is parallel to AB. So this EF is also parallel to AB, okay? And then DC is equal to 2AB. In the previous session, maybe the last rider, I hope we had proved this. That is prove that DC is equal to 2AB. That is one parallel side of a trapezium is twice the other. So that we had proved that. So that result we are using it here. That is DC is equal to 2AB. That is this length DC is twice the length of AB. So if it is 2 cm, this will be 4 cm, something like that. So BE by EC is 3 by 4. So here this ratio BE by EC, this ratio is 3 by 4. So this is 3 parts and this is 4 parts. That is, the ratio is given. So using all these data, we have to prove that 7FE, 7 times FE is 10 times AB. 7 times FE, where is FE here? Here is FE. 7 times FE is 10 times AB. So that is 7 times FE. That is the thing we have to prove here. 7 times the length of EF, that is FE, is equal to 10 times the length of AB. So that we have to prove that, right? So we'll go with the data. It will be for 4 marks. You have to be very careful. Please observe very carefully. I am going to explain each and every new corner points involved in this rider. Please follow this. So ABCD is a trapezium. Right. So very important is AB parallel to CD, EF parallel to AB, and DC is equal to 2AB. So at the end of the rider we are going to use this result. So and BE by EC, BE by EC is equal to 3 by 4. So this is the given thing. So you have to prove that. To prove that 7 times the length of FE is equal to 10 times the length of AB. So very important. So no need for any construction, nothing. So just the data what it is available here is enough to prove this. That is 7FE is equal to 10AB, right? So we'll go with the proof. Right. Now, so it is given that AB is parallel to CD, that's in the data. Let us write it down. So AB is parallel to CD, so that is according to data. Right. So now AB is parallel to CD. Along with that, also EF is parallel to AB. So AB is parallel to CD. Nice. EF is also parallel to AB. That means CD as well as EF, both lines are parallel to the same line. So if two lines are parallel to the same line, then those two lines should be parallel to one another or each other, right? So therefore AB is parallel to CD and AB is parallel to EF. So therefore, or very simple, so you can look at the figure once again. AB is parallel to CD, EF is parallel to AB. That means EF and CD are both parallel to AB. So therefore EF is parallel to CD. So therefore EF is parallel to CD. That means that is AB is parallel to EF is parallel to CD. So this is the end result. So once again, AB is parallel to CD, EF is parallel to AB, therefore EF is parallel to CD, therefore AB is parallel to EF is parallel to CD. So all the three lines are parallel to each other, right? So now, right, very important result. So this is the first part of the rider. You have to remember this. So in the first part of the rider, we have to show the parallelism of lines, right? So now, here, as AB is parallel to EF and EF is parallel to DC, then BE by EC, the ratio, what is BE by EC ratio is there, the same ratio will be here also, that is AF by FD, that is BE by EF will be equal to AF by FD, that is AF will be 3 units and FD will also be 4 units. So, as these three lines are parallel to each other, these three lines divide BC in the ratio 3:4, then these three lines should also divide the line AD in the same ratio, that is 3:4. So BE by EC is equal to 3/4. It's according to data, right? But BE by EC is equal to AF by FD. AF by FD. So therefore, AF by FD is also equal to 3/4. So this is a very important result. AF by FD is also equal to 3/4. If the ratio is given something like 4:3 or 7:2 or 5:7, don't worry about the ratio. Follow the same procedure. No changes in that. Don't worry about the ratio, right? So, if the ratio changes, prove that changes. If for example, if BE by EC is 3/4, then 7FE will be equal to 10AB. If it is 4/3, then 7FE will be equal to 11AB. Just you can try it. Just you can, in the practice problem, just change the ratio. You can make BE as 4 units and EC as 3 units. Just while drawing the diagram, please pull this line just below this, because this becomes 4 parts and this becomes 3 parts. Just in the diagram, pull the line below so that it looks like 4:3 ratio. If you do it, it will be 7FE is equal to 11AB something. So prove that changes. Don't worry about the ratio, right? So here AF by FD is equal to 3/4 we have got, right? Now select a triangle ABD. I hope you can see this. Select triangle ABD, right? So in triangle ABD, in triangle ABD, FG is parallel to AB because FE is directly parallel to AB, FG is also parallel to AB. So if a line is parallel to another line, then the part of the line is also parallel to the given line. Part of it is also parallel to that, right? So if my entire body is parallel to this wall, then the part of my body is also parallel to the wall. That's all, very simple, right? So in triangle ABD, FG parallel to AB. FG parallel to AB. So here, as FG is parallel to AB, we will write the proportionality. AB by FG, that is, in triangle ABD I will take the base, and in triangle FGD I will take the base. That is, AB by FG is equal to DA by DA by FD. That is, I am applying corollary 3 something. I hope you remember, right? So when you draw a line parallel to a side of a triangle, then the sides of the newly formed triangle will be proportional to the sides of the given triangle. So here, this will be the newly formed triangle and this will be the given triangle. That is the old triangle. This is the old triangle and this is the newly formed triangle. So in the old bigger triangle, I am going to take AB. So in the new triangle, I will take FG. So AB by FG is equal to, in the old triangle, I will take DA or AD. So in the smaller triangle, new triangle, I will take FD. Very simple. So another ratio will be BD by DG. So which is not required for us. So I am not going to take that ratio here. Very simple. So AB by FG is equal to AD by FD. So therefore AB by FG is equal to AD by FD. AD by FD according to Thales theorem. According to Thales theorem, we are going to write it. Right. So now here I am going to make this FG as the subject. I will make FG as the subject. So therefore FG, that is here, it is here. FG into AD is equal to AB into FD. I can cross multiply, or else still simple I can make it. So AB by FG, how it is, I am going to write it in the same manner. So AB by FG is equal to, what is AD here? AD is AF plus FD, that is 3 units plus 4 units. 3 units plus 4 units is 7 units. So I will write 7 units here by FD is here. So FD is 4 units. So I will write 4 units here. So I will make FG of the subject. So FG into 7 is 7 FG is equal to AB into 4, that is 4AB. So therefore FG is equal to 4 by 7 AB. So this 7 goes to the denominator. So put this in a box and let us wait for the further results. Right? So now, after what we did with triangle ABD, the same thing we are going to do with triangle BDC. That is this triangle. That's triangle BDC. So now, in triangle BDC, GE parallel to DC. Because EF is parallel to DC, a part is GE, so therefore GE is parallel to DC. So in triangle BDC, GE parallel to DC. GE parallel to DC, right? GE parallel to DC. So therefore, we will apply Thales theorem corollary 3. Corollary 3, I hope you remember once again. If a line is drawn parallel to a side of a triangle, then the sides of the newly formed triangle are proportional to the sides of given triangle, right? So in triangle BDC, GE parallel to DC, so therefore DC by GE, I hope you are getting. For the bigger triangle, I am taking side DC. For the smaller triangle, I am taking GE because they are the corresponding sides. And for bigger triangle BDC, I am taking BC, and for smaller triangle, I am taking BE. So that becomes something like DC by GE is equal to BC by BE, right? So DC by GE is equal to BC by BE. BC by BE. So this is according to Thales theorem. Right. So this is there is less space. I am not able to write the full form. In the classwork, please don't write like this. Write the full form. So now I will write how it is. That is DC by GE ratio. I will maintain that. DC by GE is equal to BC is BE plus EC, that is 3 plus 4, that is 7 units. So BC is 7 units by BE, that is 3 units. 3. So we will go with cross multiplication, make GE as the subject. GE into 7 is 7 GE is equal to 3 BC. So therefore GE is equal to 3 by 7 DC. Right? Very important result. Both the results are very important. Right? So EG, that is FG is equal to 4 by 7 AB, 4 by 7 AB, and GE we have got 3 by 7 DC. 3 by 7 DC. Right? So now, what is FE equal to? What is FE equal to? FE is equal to FG plus GE. We will write that FE is equal to FG plus GE. So FE is equal to FG, value is ready, that is 4 by 7 AB. So I will write 4 by 7 AB plus GE. GE value is ready, that is 3 by 7 DC. 3 by 7 DC. So FE is equal to, I will take 1 by 7 as common here. 1 by 7 into 4AB plus 1 by 7, if I take common, I am left over with 4AB, plus if I take 1 by 7 common here, I am left over with 3DC. 4AB plus 3DC. So FE is equal to 1 by 7 into 4AB plus, what is this DC equal to? Come back to the data. What is DC equal to? It is 2AB. So substitute 2AB in place of DC. So 2AB. Okay. So FE is equal to 1 by 7 into 4AB plus 3 into 2, 6AB. Okay. So FE is equal to 1 by 7 into 4AB plus 6AB is 10AB. 10AB into 1 is, FE is equal to 10AB into 1 is 10AB by 7 by 1. Go with cross multiplication. 7 into FE is 7 FE is equal to 10AB into 1 is 10AB. So this is what we had to prove. So hence it is proved. So this is for 4 marks. Don't change anything. You can write the reason here. So DC is equal to 2AB. You can write one of the reason there. So this is how the problem for 4 marks comes. This is very important problem. You have to practice this well. So change the ratio to 3:4 as 4:3. Change the ratio to 2:5, something like that. Try your own writers, right? So this is very important. Go with the second problem. So in the figure AE parallel to DB, AE is equal to, sorry, BC is equal to 7 centimeter, BD is equal to 5 centimeter, BC is equal to 4 centimeter, CE is equal to 12 centimeter. Find AE and AC. Find AE and AC. Right. So this is the diagram. Right. Okay. So in the figure, AE parallel to DB. AE is parallel to DB, right? BC is equal to 7. So BC is 7 centimeters. BD is 5 centimeters. BD is 5 centimeters. Okay. BC is 4. DC 4 centimeters. CE 12 centimeters. EC or CE it is 12 centimeters. Find AE. You have to find the length of AE and you have to find the length of AC. Right. So here, in order to find the length of AE and AC, we have to select these two triangles and first prove that they are similar. So if you want any two triangles to be similar, then you have to prove that they are equiangular. If you want any two triangles to prove that they are equiangular, you have to prove that any two pairs of corresponding angles are equal. So if we do this, we can reach the similarity. After similarity, when we take the proportionality of the corresponding sides, we can reach to the unknowns. So this is the mind map for the problem, right? So in triangle ACE and triangle DCB. So in triangle ACE and triangle DCB, okay. As these two lines are parallel to each other, angle EAC, that is this angle, is equal to angle CBD, this angle, okay. Angle EAC is equal to angle CBD. So they are alternate angles. So another pair we can take alternate angles here. So angle AEC is equal to angle CDB. This angle AEC is equal to angle CDB. Angle AEC is equal to angle CDB. Reason is alternate angles again. Okay, enough. So in these two triangles, two pairs of corresponding angles have become equal. So therefore, triangle ACE and triangle DCB are equiangular. They are equiangular. So therefore, triangle ACE is similar to triangle DCB. So this is according to AA criterion, right? So we have got the criteria, that is similarity. Now we can go with the corresponding sides. So we can mark the third angle here. This is, and these are the third angles which are equal. Okay. So this and this angles are equal, therefore they are corresponding angles. This angle is equal to this angle because they are corresponding angles, and this angle is equal to this because they are corresponding angles as they are equal, right? So now we will mark the proportionality. So for the third angle, we will start with the third angle. So in triangle AEC, for the third angle opposite side is AE, and in this triangle for the third angle opposite side is DB, that is AE by DB. AE by DB or BD, anything, right? So in this triangle we will go with the first angle. So for the first angle opposite side is EC, and for the first angle opposite side is CD. So EC by CD is equal to, for the second angle opposite side is AC, and for the second angle opposite side is BC. So therefore AC by BC. AC by BC. So reason is corresponding sides are proportional. Corresponding sides are proportional. Right. We will put the values. So AE, I don't have the value for this. AE, I don't have the value. DB, I have the value, that is 5 is equal to EC. EC value is 12 by CD. CD value is 4 is equal to AC. AC value I don't have. So AC by BC. BC value is 7. Right. So now I hope you got the clarity here. So you can equate these two and find out the value of AE, and equate these two and find out the value of AC. That's very simple. So we'll equate these two. So AE by 5 is equal to 12 by 4. 12 by 4, 4 ones are 4, 3 side goes. So AE into 1 is AE is equal to 3 into 5 is, that is 3 into 5 is 15 centimeters. So what is the length of AE? That is 15 centimeters. Now equate these two once again, because out of 4 elements you have one element as unknown. You can just equate these two. So AC by 7 is equal to 12 by 4. AC by 7 is equal to 12 by 4. 4 ones are 4, 3 side goes. So AC into 1 is AC is equal to 7 3s are, it is 21 centimeters. So length of AC is 21 centimeters. So this is a beautiful numerical on AA similarity criterion. Right. We'll go with the next problem. In triangle XYZ, P is any point on XY. P is any point on XY. Okay, and PQ perpendicular to XZ. PQ perpendicular to XZ. Very important. If XP is equal to 4 centimeters, XY is equal to 16 centimeters, XZ is equal to 24 centimeters, find XQ. We'll go with the diagram. Right, very peculiar problem. Most of the students have lost their marks in the examination while solving this problem, particularly this problem. Let's see why they lost and how we are to gain. Right. So in triangle XYZ, so this is triangle XYZ. P is any point on XY. P is any point on XY because P doesn't have any criteria here. It's not the midpoint of XY, nor it divides the XY in any ratio. It's some point on XY. Okay. So PQ is perpendicular to XZ. So it is done. So perpendicular symbol I have put here. If XP is equal to 4, XP is equal to 4 centimeters. So this is 4 centimeter here, and XY is equal to 16. So XY is this one, that is 16 centimeter, right? That is entire XY, and XZ is 24. XZ is 24 centimeters. So this is XZ which is 24 centimeters. So if this is the thing, find the value of XQ. That is, we have to find this length. We have to find out this, right? So very, very beautiful problem. Most of the students lose marks. I'll show you how they lose, and you have to be very careful here. Right, let us, as it is a numerical, I will directly go with the solution. Right. So here we have two triangles here. One is triangle XYZ and triangle XQP. So two triangles we have here. So first we will prove that both the triangles are similar by proving that they are equiangular and by proving that their corresponding two pairs of angles are equal. Right, that is the mind map. Once we prove that they are similar, then we can discuss regarding their corresponding sides. So by using the corresponding sides proportional property, we can go with the unknown. Right. So in triangle XYZ and triangle XQP. Right. So in triangle XYZ and triangle XQP. Right. So in both the triangles, angle XYZ is equal to angle XQP. Angle XYZ is equal to angle XQP. So both are equal to 90 degrees and it's according to the data. Right. Then as this triangle is inside this big triangle, so therefore they should have an angle which is common to both the triangles. So here this angle becomes the common angle. So angle YXZ in bigger triangle is equal to angle PXQ in the smaller triangle. So angle YXZ is equal to angle PXQ. So it is common angle. Right. So in both the triangles, in two triangles, two pairs of corresponding angles have become equal. So therefore both the triangles should be equiangular. So therefore triangle XYZ and triangle XQP are equiangular. Right. So therefore triangle XYZ is similar to triangle XQP according to AA criterion. Right. So now we will go with the corresponding sides. Very important. Now, in the bigger triangle, the side opposite, the side opposite to the 90 degrees is XZ. So therefore XZ by, in the smaller triangle, this is 90 degrees. Opposite to that is XP. That is XZ by XP is equal to, in the bigger triangle, opposite to common angle. This is the common angle for both the triangles. So opposite to common angle in big triangle is YZ. Opposite to that is YZ. So YZ by, in the smaller triangle, opposite to common angle is PQ. That is PQ is equal to, let us now identify the third angle. So in big triangle, that is triangle XYZ, this becomes the third angle, and in the smaller triangle, this angle becomes the third angle. So opposite to the third angle in big triangle is XY. So this is the third angle, opposite to that is XY. In the smaller triangle, this is the third angle and opposite to that is XQ. So XY by XQ. XY by XQ. So this is corresponding sides are proportional. Right? Okay. So let us see which ratio we will ignore. So one is XQ we need, so this ratio is required. So XP is required, so this is also required. So YZ by PQ. YZ by PQ, let us ignore this. And we will consider only these two ratios. So XZ by XP is equal to XY by XQ. Now we will substitute the values. So what is XZ from the figure? From the figure, XZ is 24 by XP. XP from the figure, it is 4 centimeters, is equal to XY. XY is entirely, it is 16 by XZ, that is you have to find out. Sorry, XQ we have to find out, right? So for 1 times, for 6 side goes, so 6 by 1 is equal to 16 by XQ. So 6XQ is equal to 16 So xq is equal to 16 by 6. 2 3s are 2 8s it goes. So xq is equal to 8 by 3. So when you divide 8 by 3, so 3 2s are 6 point 20, 3 6 are 18, 2.6 centimeters. Right, so xq is approximately 2.6 centimeters. So most of the students where they lose marks is while writing the corresponding sides of similar triangles. You have to be very careful because the entire triangle is a mirror type. For this triangle is the mirror type. So that is what we call lateral inversion in physics, particularly light chapter. I hope you have studied in your physics. So for triangle XYZ, XQP is inversely lateral this one. So therefore you have to be very careful in identifying the corresponding sides. So approximately it is 2.6 centimeters. Okay, we'll go with the last problem. In trapezium, ABCD, AB parallel to CD, AB parallel to CD, OA is equal to 3x minus 19, OC is equal to x minus 5, OB is equal to x minus 3. See, please remember always binomials should be kept inside brackets. OD is equal to 3. So therefore find x. So this is the diagram given. So in trapezium ABCD, AB parallel to CD, right? OA is equal to 3x minus 19, that is this one. So this is 3x minus 19 and OC is x minus 5. OC is x minus 5, right? And then OB is x minus 3. OB is x minus 3 and OD is just 3. It is just 3 units. So you have to find the value of this x which is involved in the corresponding sets. So for this the answer you are going to get it as x is equal to 8 or x is equal to 9. So this is the answer. Right, at last you are going to get. So what you have to do is select these two triangles. Select these two triangles, that is triangle AOB and triangle DOC. Prove that they are similar by showing that their two pairs of corresponding angles are equal. So in triangle AOB and triangle DOC, angle BAO is equal to angle OCD. So this angle is equal to this one pair, and angle ABO is equal to angle ODC, this pair, right? So hence triangle AOB and triangle DOC are equiangular, and hence triangle AOB and triangle DOC are similar. So after that, take the corresponding sides. AB by DC is equal to OA by OC is equal to OB by OD. This is the corresponding sides. Put the values, go with cross multiplication. Put the values in that and go with cross multiplication. Don't use AB by CD, it's of no use. So don't take that ratio, just ignore the ratio. Take the ratio, OA by OC is equal to OB by OD ratio. Go with cross multiplication. Go on solving it. You are going to come across a quadratic equation. So in the sense you have solved regarding quadratic polynomials, how to get the zeros of quadratic polynomials, you have solved it. So in the same method, go on doing it by using the sum and product method, that is searching of two numbers which gives the sum which is the middle number and product is the last two numbers, right? So do it. At last x is equal to, you are going to get it as 8 or 9. So please do it in your classwork and send me through WhatsApp, right? So I hope you enjoyed the entire session today. All the 4 problems are very important. Please don't ignore anything. Practice problems. Get ready for a test on Sunday until what it is done until Saturday, right? So please prepare yourself well, do well in the test. So until that, stay home, stay safe and keep learning, right? Thank you.